Hi again. So this is lecture number 4, and lecture number 4 is behind this card here. A couple of topics, separate topics as well being covered in this lecture. The first thing I want to look at is the area of design patterns, where we're going to discuss design probably at the kind of component level rather than at the app level. In the next lecture, I will talk about app level design, where we come up with the component hierarchy and decide which components are stateful and stateless, all that kind of stuff. That's for next week, but the next lecture. In this lecture, I'm going to talk about the internals of a component, let's say, and how we might better structure the code. Secondly, I want to continue to look at some more navigation or routing samples from the set of samples that I started to look at last week. Basically, I'm covering the routing samples as we need them for the labs. So that's why I'm taking the approach of splitting them up across a number of lectures rather than covering them all in one lecture. And the third topic that I want to cover in this week's lecture, or in this lecture, is custom hooks. Hooks are a key part of design, especially because it is linked to design in modern day React implementation. And we can implement our own hooks. And I'm just going to give you a simple illustration of a custom hook that we can implement. And we'll do it in the lab as well. There are more elaborate aspects to hook design, which we won't get into. The lab, as expected, is a continuation of the Movies app that we're developing from the previous 2 lectures. And there's also an archive, and the archive this week is linked to our discussion on design patterns. So the title, Design Patterns, is not specific to web apps. It's actually an aspect of software engineering in general. And just by definition, what a design pattern is, and it's specified there at the bottom of the screen. A design pattern, I'm saying, is an abstracted, repeatable solution to a commonly occurring problem in software design. So kind of what has happened really over the decades is that as software engineers, we have been coming across similar types of problems that we want to implement solutions to. I'm talking about problems now at the micro level rather than at the macro level. And over time, the design of these solutions are good quality designs to these problems have kind of emerged, and they've been cataloged and documented for the rest of the community to use them, really. In fact, the text, the image there that you see on the left is the cover of a text that was published way back in 1994. So, as a topic, it has been around for many, many decades. Now, I want to relate it to web apps, and specifically to web apps developed using the React framework. You can see there from the book title, it relates more to the world of object-oriented development, so languages like Java, C++. But even the design patterns that were documented in this text, they can be actually applied to areas of web development as well, as it turns out. So anyway, this is what design patterns are. They are well-founded, abstracted solutions, design solutions to commonly occurring problems in the area of software development. Now, in relation to software design, reusability and separation of concerns, I'm sure you've heard of these before. These are kind of high-level design objectives that we have. By reusability, what we're trying to get at there is the ability to implement modules or units. Units now in the context of a React app would be a component. A unit in the context of object-oriented Java development might be a class. We're looking to develop units that are reusable either within an application or across applications. By separation of concerns, we mean we'd like each unit to really just have one single responsibility. And why is that a good idea? Well, it's probably easier, it's more directed at maintainability and understandability. If each of the units within our overall application has a single responsibility, and provided it's well named, then it's easy for other people to understand our code. And also, it's probably easier to maintain our code. So we'd like to achieve these. They're kind of interrelated, the two objectives, and they are a design objective. Related to this is the notion of the DRY principle, where DRY stands for don't repeat yourself. The idea being that nowhere within your code base for a particular application should you have code that is repeated multiple times, albeit there may be slight differences between the repetitions, but it's obviously not a good idea. What we would obviously do in that kind of situation is to abstract the repeating code, put it into a unit of its own, and reuse it wherever it needs to be used. So dryness, reusability, separation of concerns, single responsibility, these are all objectives or principles of good software design, whether it be web app development or any other type of software development. Now, in order to try and achieve these, there are, in general anyway, two kind of approaches that you might take to modeling your problem domain, as we say. So whatever you're trying to develop an application for, that's what we're calling the problem domain. And we're analyzing the problem domain and we're trying to come up with some sort of overall high-level design for it. Then when you're analyzing the problem domain, you can either view it through the prism of inheritance or through the prism of composition. What I mean by that is with inheritance, you're looking for is-a type relationships in your problem domain. So for example, a car is an automobile. So if I was developing an application and car and automobile would be concepts in the problem domain, then if I was using an inheritance approach, and let's supposing I was using a language like Java, then I would have a class of type automobile and I would have a class of type car, where car would inherit from the automobile class. That's your typical inheritance type relationship. An alternative way of viewing your problem domain is to use a composition approach. Now, this is probably going to be less familiar to you. You are certainly familiar with inheritance, but in a composition approach, what you're looking for is often referred to as has-a type relationships. And to stick with our case kind of study, if you like, we might say that a car has an engine. And so we would model that. We would maybe have a car class, but one of its properties would be an object of type engine. So it's just two kind of different ways of looking at the world and modeling the world. That's what we're trying to get at here. And they're equally valid. But as it turns out, the React framework veers towards the composition model, which is really where I want to take this discussion. And it's also going to be something new for you. Now, in that vein, taking a composition approach towards modeling a problem domain and trying to achieve greater reusability, better separation of concerns, improved dryness in your code base, then the patterns, there are three patterns that have emerged in the React world over the years, and I'm listing them there. And I just want to look at each of them and show you examples of code using each of them. And we will also use, well, we'll use the first two in the Movies app. We don't get an opportunity to use number 3, but you may see an opportunity to use the third one. in your own assignment, maybe later on, although that's not necessarily a high-level requirement that I have. So these are three patterns, three design patterns based on the composition modeling approach that we would like to use in our React code base. Before I talk about the three patterns, just to get a term out of the way, HTML, as it turns out, actually, HTML, if you could, it's a language in a sense, but it is based on the kind of composition approach. And the two little code excerpts that I'm showing you there, then the way we might express it is to say that if we take the one on the left, we would say that a div is composed of a H2 and a UL, or at least this particular div is, whereas on the right, I have a div that is composed of a paragraph and an image and a hyperlink. So HTML actually allows us to compose elements in any way that we want to. If we go back to the excerpt on the left, then we would also say that the div has two children, H2 and a UL, and on the right, our div has three children. So it's this term children that I'm just introducing here, because that actually comes into play when we start looking at React components and composing React components with other components. So the first pattern we will look at is the container pattern. Now, I'm saying here that a React component has a special prop called the children's prop. It has been there all the time, but we haven't used it up to now. And what it allows us to do is to pass components to other components. And we do that by nesting it within the JSX. So if you see my simple picture component here, in the middle of its JSX, I'm referring to the children prop. So how does this get its value? Where does it get its value from? But whatever it evaluates to, it's obviously going to be inserted into the middle of this JSX of picture. And on the right, I'm showing you in general how you control the children prop. So whatever you put here is going to be bound to the children prop of picture. And you can see the way that I'm using picture here. I have its open tag and its closing tag. This is very HTML-like, and that's what's nice about React components. We can follow the same type of syntax as we do with ordinary HTML tags. So whatever goes in here gets essentially bound to this expression here, and so will be displayed here. And so that what this effectively allows us to do is to decouple the picture from what it includes in its output to the screen. And hence we can reuse picture in many different scenarios. So it's this idea of decoupling is one of the outcomes. And so if we take a couple of illustrations, what it now means is that if I take this example here, where I'm using picture, but in this case, I am telling it I want to include a button with the picture. So the image is going to be displayed and the button is going to be displayed. The image is coming from the picture component itself. If I go back to the previous slide, the picture displayed an image. Okay, we passed it what the URL of the image was. We didn't worry about that. But what it displays after the image is up to what we're calling the consumer. The consumer is the component that's using the picture. So for this example, it's going to display a button. Whereas here, I'm getting it to display a list with the image. Here, I'm getting it to display whatever my complex component is. with the image. So I'm reusing the picture for different use cases, and that was one of my objectives, this idea of reusability. Another way I could describe what's going on here is to say that my picture is being composed, my picture component is being composed with other elements or components. So that's the kind of classic example of composition going on. The next pattern is the render props pattern. And okay, the statement that the objective of the pattern is to share logic between components. I guess that would be true really of all of the patterns that I'm going to show you in this lecture. It was true of the container pattern that we've just looked at. And it's also true of the render props pattern. They all kind of have the same objective. Indeed, most patterns have this objective of reusability, but you would use certain patterns in certain situations, or maybe you could only use certain patterns in certain situations in order to achieve that reusability objective. So for the render prop pattern, first of all, we need to explain what a render prop is. And I'm saying a render prop it's a prop that is a function, but when that function is invoked, what it returns is a component or JSX. And so it's going to be display whatever that JSX specifies. So a render prop is a function prop that a component uses to know what to render. So you would pass a render prop to a component, and the receiving component would then invoke that render prop because it is a function, and the function is going to return some JSX, and so it's just going to display that JSX. So it's the same idea really, in a sense, of passing components to other components, except this time we're doing it via a traditional prop rather than the built-in children prop. Again, a 101 example. So you can see here in the middle of my component, I am going props.render, but this time I'm using render as a function because I said that at the top that the render prop is a function. So I'm invoking the function. So whatever this expression evaluates to, in other words, whatever the render function returns, which will be a component or some JSX, that's going to be inserted into this overall JSX of what I'm calling my shared component. Here's an example of it being used, and again, it's a 101 kind of example. So I'm using my shared component, and I'm passing it the render prop explicitly, and it is a function that's being assigned to the render prop. It's an arrow function, it's a one-liner, so I don't need the curly braces or the return statement. So this function here returns, it looks like a span, which means if we kind of looked at the runtime outcome of this overall piece of code here, it would look like that. So the div and the on mouse click handler, all of that is coming from up here. The span is coming from the render prop and the closing div. So again, so the shared component receives its render logic, that being just the span in this case, it's pretty trivial. It receives its render logic from the consumer. The consumer, again, is the component that's actually using my shared component. That's the terminology that we use. Here's a better illustration of the render prop, or a more real-life illustration of it. So I'm going back to my friends list app that we had from the previous lecture, and whether these are two different pages on the same app or two different apps, either way, it looks like that for the one on the left, I want my friend component to, or my list of friends to include the friend's name and an image. That's how I want them rendered. Whereas on the right, I want the friends to be displayed as their name and their email address. So there's clearly an opportunity to have some reusable components between those two pages. Now, we know from the previous lecture that this was the design that I gave you in the previous lecture. But the problem with the design is this relationship here is actually hard-coded, which means that this component, the only way it's going to work is by rendering friends as they are encoded in this particular component. Whereas on the previous slide, I have two different ways of rendering a friend, but I'd still like to be able to reuse this component because what it does is going to be the same between my two applications on the previous slide. It's going to map over an array of friends and produce the output, but the output that it produces is going to be different. So this kind of hard coding or hardwiring or static relationship isn't going to work for me. I'm still going to be passing my friends, my array of friends down into this component. And this is the one actually that's going to be changing now as a result. But as well as passing the array of friends, what we'll see is that I'm going to pass down an additional prop, which is going to be my render prop. And that prop is going to enable my filtered friends list to display my friends in the way that I want them to be displayed, whether that be their name with an image or their name and their email address. So this design isn't going to work. And so I'm telling you on the right what the solution is. The solution would be to pass not only the list of matching friends, but also pass down as a prop a way of communicating to my filtered friends list how it should display each friend. And I'm going to do that using the render prop pattern. So here are some excerpts from the app itself. The one in the middle is showing you the component that is receiving the render prop, and the excerpt on top, and the one at the bottom is showing you two examples of using the component that is past the render prop. So if we take this one, so we're passing our component the list of friends, and via the render prop, we're telling it how it should render each of my friends. So this component, as we'll see in a while, this is the one that generates the friend's name followed by their image. Whereas down here, I'm using the exact same component, but this time the render prop is telling it to render the friend in a different way. This component, as we'll see, is the one that displays a friend's name followed by their email address. And here I have within the shared component, this is the shared component in this case, because it's being used here and it's being used here. I'm just simply invoking, I'm mapping over my friends as before, but for each element that's mapped over, I am invoking the render function that has been passed into me. In other words, this function here. I'm invoking that, and I do need to pass the friend that's currently being processed because it's being actually used here. So that means that this variable here, friends, it's going to be an array of components, and what type of components it is going to be depends on what this function invocation returns. So in the case of this use of it up here, my friends array is going to be an array of components of this type. Whereas when I'm using it down here, the friends array is going to be an array of components of this type. So the filtered friend list saying is no longer statically imported. If you look back at the filtered friends list component that I gave you last week or in the previous lecture, I actually had an import statement here where I statically imported the friend component. And so I was bound to rendering my friend in a particular way. Whereas now I'm being told by the consumer, this is my consumer up here and down here, I'm being told by the consumers how to render the friend. So I no longer have a static import of the friend. It's received via the friend's prop, or the render prop instead. And yeah, so what I'm saying here is that if I didn't have the render prop pattern, then that would mean I would need to have two instances of this component. One which renders the friends in one way and the other one which renders the friend in the other way. And they would be statically importing the particular friend component code. So I'm reusing this in two different scenarios in my case. And the last point down here is, I think I've mentioned in passing, the name of the prop isn't really significant. It's just by convention, it's referred to as the render prop, essentially because it's telling the shared component what it should render on its behalf. Now to get the full app, as I said, just grab the archive. So you'll get something like this here. Now I'm using this project for another example as well later on. So some of the components don't relate to what I'm talking about at the moment, but if I expand the source folder, and app is, if you remember, my component at the very top of the hierarchy that has all of the state associated with it. So we've seen all that from before. There's nothing new there. So what is new is the way I'm using the filtered friends list, which we've already seen. And at the very top, I've got a couple of imports that I'm just going to swap in and out rather than having multiple applications. So at the moment, I'm importing friend contact, and friend contact is this one here. And that's nothing new really. We've seen that before. And I guess if I just run it, so it looks the exact same as before. But the beauty of the way that I have redesigned it, and in particular, I've redesigned the filtered friends list, the benefit comes as follows. If I go back to my app.js and I comment that out and bring in this one. And now down here, I change this to save it. and now my friends are being rendered in a different way. Next, we look at the higher order component option here for implementing composition. And to give you a definition of what higher order component is, it's a function, number one, which you may not get from the name, but it's a function that takes a component as an input and it returns an enhanced version of that component. So you can see kind of from the signature here, it's as simple as that. The input is a single argument, which is, okay, it's actually going to be a function because we know that now that components are implemented as functions, but it takes a function as its input and it returns a function, but the function that it returns is also going to be a component function. And it's essentially going to be a kind of a wrapper around the input function that it received. But from a React point of view, it takes the component and returns an enhanced version of that component. And I'm documenting down here what I mean by possible enhancements. So it may take the input component and add some state to it, or it may provide some additional props to the input component. Thirdly, it may change the input component's UI. By change, I mean it would add something to it. Or it could be a mixture of some or all of those three enhancements. There's a convention as well, a naming convention associated with these higher order component functions, which is that you prefix them with the keyword with. The idea being that the function takes a component and it returns that component with some additional enhancements. Now there's a little sample app demonstrating this higher order component idea. And so what you see here is on the left, I have a list of friends, and on the right, I have a list of movies. And I want to make movies and friends clickable. Clearly, those two components are very different types of components. And by clickable, in the case of a friend, I just want to add a button once the friend has been selected. Now, presumably there would be some behavior behind the clicking of that button. We needn't concern ourselves with that. But it's just displaying the button once a friend has been clicked on. So it looks like these two have been clicked on, and if I clicked on the same friend again, the button would disappear. That's the behavior that I want. On the right, I have my list of movies, and by making a movie clickable, I want the reaction to be to draw a box around that clicked or select movie. So in both cases, the idea of making the components clickable, you'd imagine that the outline of that clickability is common to both of them. The specifics of what a component does when it is clicked, that's unique to the component, but the outline behavior is common to both of them. So if we've ever got something common to two or more components, then we like to abstract that into something separate. And the something separate in this case would be an implementation of a higher order component function. Before we look at the specifics of the code for that little sample, here I'm showing you the kind of template for any higher order component implementation. So it's kind of consistent with what my definition was. Here I'm declaring it, and it looks like, well, yes, it is a function because here's my arrow function implementation. It's taking a single argument and it's returning all of this here. And all of this looks like it is a function as well, but it's not just any old function, because if we looked at the return statement for this red section here, the return contains JSX. So that must mean that this function here is also a component. And that is, again, aligns with how I defined higher order component. So it's returning a component and it received a component. And what you put in here then is the additional stuff that you want to wrap around the input component, whether it be behavior or some additional JSX or some additional props. The props would have been computed in here, and then they would be passed into the input component that was received. So if I go over to the code, it's actually the same project or the same archive that we downloaded for demonstrating the render props. So the way we convert this over into using the higher order component idea is to go into the index.js and simply change this line here so that it now refers to app2. App2 being clearly this guy here. And if I save that and go over to my browser, then here's this idea of clicking on a friend and clicking on a movie. So just some excerpts from the code. First of all, if we look at the higher order component implementation itself, it's quite small, but it's quite tricky at the same time. So here I'm returning the enhanced version of, so clearly this, in this case, the component that's being passed in would either be a movie component or a friend component, although the higher order component implementation doesn't need to know that clearly. And it's returning all of this here. And what am I doing? I'm actually declaring a state variable. So making a component clickable will mean adding a state variable to that component. And the way it's going to work is that every time the user clicks on the component, we're going to set the state variable to true. If they click on it again, it goes to false. So true means the component is currently clicked on. False means it hasn't been clicked on at all or has been deselected. And this is just an event handler for handling the clicking action by the user, the click event handler, in other words. So it's fairly straightforward. And what am I returning? Well, in the body, in the middle of what's being returned is the input component that was passed in, but I'm just wrapping it in a div, and the div then is what's making the component clickable. Now we can't see from here, what does the component do as a result of being clicked? That's going to be specific to the input component itself. And we'll see that in a moment. But notice as well over here that I'm passing down to the input component the current value of my state variable up here. Because the component needs to know, the input component needs to know, has the outer component being clicked on or not. So this specific higher order component, it's doing three things. It's adding a state variable to my input component. It's also adding an event handler. It's passing an additional prop down to my input component. And it's also enhancing its JSX by wrapping it in a div. The input components then, I'm just showing you one of them. So in the case of the friend, what I want to happen is for a button to appear beside the image as a result of the friend being clicked on. And so all that's required to achieve that is to check you can see here, I'm checking the props.clicked property. And if it's true, then display my button. If it's not true, then essentially do nothing. Now, what's also critically important here is that I'm not exporting this component here. What I'm exporting is what the with clickable higher order component function returns. I'm calling the function here, passing in my friend component, and whatever that expression returns, that's what I'm exporting. And of course, we know from the previous slide that what this is going to return is essentially this component here, which has the state variable, et cetera, and the on-click handler. So I'm exporting, if you like, I'm exporting the output of the with clickable function. And, you know, that's what you are going to be using in the rest of your app. So clickable friend here is going to be correspond to whatever was returned by this function. And notice as well that all I need to pass in terms of prop to this component are the props that would be expected up here. I do not pass in the clicked prop. That's taken care of by the function. So it's a little bit tricky, but if you see one or two examples of it, you'll notice then that really all higher order component implementations are variations on that. So get an understanding of one or two implementations and you have the pattern at that stage. If I just go over to the code, then maybe, so we've seen the key parts, but in terms of the app2.js, all that's going on there really is we have our two state variables to store our list of friends and our list of movies. I use effect hooks that make the API calls. And then I'm mapping over my friends and mapping over my list of movies. And in the case of this component here, this is what I'm importing from this file here. And that file is the one that I essentially showed you there a moment ago. There's my clickable friend, but as I've already highlighted, I'm not exporting this guy. I'm exporting what that function returns. And the rest is, so the only components that are relevant to this illustration are clicked friend, clicked movie, app2.js, and the with clickable implementation itself. So have a browse around that code. Now, just in summary then, so like the first 3 bullet points here, you could take those as being relevant to any type of software development. In any type of software development, your objectives are always to try and achieve reusable components or elements or units within your code base, whether a unit is a class or a function or a component in the case of React. You're also looking for good separation of concerns between the units that make up or modules that make up your code base. You're always trying to achieve this dry objective. So these are generic software development objectives. Why do we try and reach for these objectives? Well, to get these benefits of what are referred to as the ICT benefits: maintainability, understandability, extensibility, adaptability. These are all very good generic software development characteristics. And how do we approach reaching these objectives in order to get these benefits? Well, the answer is to apply design patterns, well-founded design patterns to your code base. Then moving specifically into the area of React app development. We now know that that means, in terms of patterns anyway, using the composition patterns that I've shown to you. Now, there's a little caveat actually, which is since React, the React team introduced hooks into its programming model. And you might remember that was really only around early 2019, whereas the React framework was open sourced back in 2013. But since hooks, which was quite a novel programming construct, since they were introduced into React, to be honest, the use of higher order components and to a lesser degree render props, the use of those two patterns has somewhat diminished. There are still good use cases for them, but they're not as commonly used now as this hooks approach. But I still think it's worthwhile familiarizing yourself with the patterns, and you'll see me using the container and render props pattern in the Movies app. I could have used higher order components as well, but I chose not to. Now, apart from these composition patterns, there is one other pattern that I'm going to look at, not in the next lecture, but I think in the last lecture. So we've that to look forward to. Now, I want to go back to this area of navigation or routing. It was a topic I introduced in the previous lecture, and we worked our way through some samples. But as I mentioned back then, there were a couple of samples that we didn't get to cover, and I want to look at some of those in the remainder of this lecture. So you need to dig out the archive from the previous lecture if you want to play with these samples. What I'm showing you here is the typical kind of layout that we tend to get for all web apps or most web apps. By that, I mean, there tends to be this idea of having some sort of static header and footer for each page in a web app. They would typically contain navigation links. There might be a side menu as well that remains static. By static, I mean even as you navigate from page to page, these three elements remain constant or consistent across all of the pages. And it tends to be this area here of the page that changes as you navigate around an app. So how do we actually achieve these kind of constant header and footer and maybe side menus in the case of a React app? And it's part of the implementation of navigation and routing, I guess. By way of illustration, I want to have in my web app a constant header that looks like this and a footer that looks like that. And I want that to be consistent across all of the pages of my app. And it's quite easy really as to how you might achieve this. In the case of React Router, it refers to this constant header and footer as being persistent elements or persistent components, as in they persist across all of the pages in your web app. And the way you implement it is in part of the routing configuration. So if this is your typical routing configuration, then you'll notice that I have a component here called header. So that's just a custom component that I implement, and what it renders is whatever you want your persistent header to be across all of the pages. Similarly, I have a footer component. The names of them is arbitrary, but in my case, the footer will render that persistent page footer for all of the pages in my app. And you'll notice that both of these components are kind of lying outside these route entries. So the route entries will determine what will be in the dynamic part of my web page. These will be consistent across all of my web pages. And these are just standard components. They can contain whatever you want them to be, but because I've positioned them here in my routing configuration, it means they're always going to be visible as I navigate from page to page. So this is sample 6 from my routing samples. So just to see it in action, you know the drill now at this stage. You go into the index.js at the top of your set of samples, change it to the sample number. I need to start my server, of course. Save my change. And as I navigate from page to page, the header and the footer down at the bottom here remain constant. Now, in terms of the these navigation links here, we could use the link component to implement those, and that would work fine. But the React router does provide an alternative component called the nav link component. So it's somewhat optional, but I've used it in the demo, and I'm also using it in the Movies app. And the benefit that the nav link has over the link component is, as I'm seeing here, you can kind of dynamically control how the styling associated with the hyperlink. If I go back to the browser, in my case, what I wanted was whichever page is currently being displayed, like if I go to the home page, then the home link in my set of navigation links is, its styling is different from the other ones. If I move on to the about, so that's the styling that I wanted to achieve. Whichever link in my set of navigation links was selected, its styling would be slightly different from the other ones, just to indicate that that's the one that's currently being displayed. And the way I did that then is, here's just two examples of the hyperlink navigation links implementation. So I'm using the nav link component. It has a tub prop, just like the link component does. But you see here in the class name prop, what you can do is implement a function, and the React router will call this function. It will pass into it a Boolean, and that Boolean will either be true or false. And if it's true, it means that this particular link has just been selected. If it's false, it means it hasn't. And so what I'm doing is I am, via destructuring, I'm accessing that Boolean variable. You call it anything you want to, but, well, sorry, you don't have the option. It has to be called isActive. That's prescribed by the nav link component itself. And you can see what I'm doing here is I'm checking to see, is the isActive Boolean true or false? If it's true, use this styling. If it's false, use this styling. And each of my nav links has the exact same implementation of this function that's being assigned to class name. So the React router will take care of invoking this function for us. That's the way it works. So you'll find those implementations, the full set of implementations, in the header component in sample 6. There you can see all my nav link implementations. There is one link implementation. The link implementation corresponds to this hyperlink here on the left. I could have used nav link there if I wanted to. So that's that. The next aspect of routing and navigation is this notion of programmatic navigation. So far, the only way we can achieve navigation in our React app is via hyperlinks, whether those hyperlinks are implemented with the link component or the nav link component. But there are occasions when you actually want to implement navigation within your JavaScript code, maybe as a result of some event handler executing. Within that event handler, it wants to send the user to some other page in the app. So the objective here, or the idea here, is to perform navigation in your JavaScript code rather than via some JSX components. Now, there's two ways we can approach implementing this, and in many cases, it's just a question of which style you prefer. There are some cases where you have to pick one of the two options, but we can take a declarative approach towards implementing programmatic navigation or an imperative approach. If we take a declarative approach, then what you'll see, and I have an illustration of it, is you will need to have a state variable associated with the component. And that state variable is going to be used to control the navigation. And also we'll use another component provided by the React router called the navigate component. If we take, alternatively, we can implement programmatic navigation using an imperative programming model. With the imperative programming model, we don't need any state variable. We use a hook provided by the React router called the use navigate hook. And we'll see an example of that as well. By way of illustration, which is in sample 7, typical kind of use case for programmatic navigation is the following. If you've got, let's say, a register user link available to the user, and I've implemented this register user both in a declarative way and an imperative way, so you see both options, but they both behave the exact same way. So these two now are just ordinary hyperlinks. And the idea is if the user clicks on them, it brings them to the registration page. Now I've left out the actual filling in of a registration form. We're not concerned about that. But let's imagine there is a web form here that the user fills in, and then they click the register button. That will have an event handler associated with it. The event handler will possibly do some validation on the inputs that have been supplied by the user, send the data back to a web API, et cetera, et cetera. Eventually, we want the application to send the user back to the home page. So we want a redirection over to here. But it's this final part. How do we actually implement that? Because it has to be implemented in the event handler associated with the button. And the answer is, well, we can implement it using programmatic navigation, either using the declarative approach or the imperative approach. So this is sample 7. So let's set up our set of samples to now look at sample 7. So as I said, if I take this option here, when I click on register, it sends me back to the home page. Similarly, this one sends me back to the home page. Let's drill into the code. So this is fine. So here are I have 2 routes and I've just given them kind of descriptive names for ourselves. So register D for declarative and register I for imperative. Here are the 2, I could have used navlink now, but I just used the ordinary link components. So these guys implement my 2 hyperlinks at the top of the page. And you can see if the user clicks on this one, changes the browser's URL to /registerd. That matches up with this route here. And so this component is mounted. So I guess if we look at this component, it's going to be responsible for displaying the registration page. And the name is telling us that I've implemented programmatic navigation using the declarative approach. But here it is. So nothing unusual. Okay, I've got a state variable here, and I'm going to be using this state variable to control sending the user back to the home page. Remember, I said in my slides, if you want to implement programmatic navigation using a declarative model, you're going to have a state variable to support that. So that's what this state variable is going to do for me. So the first time this component executes or renders, then what's it going to do? It's going to instantiate that. That's okay. This is just a declaration of an event handler. It's checking my state variable to see if it's true, which it's not going to be. So it's going to skip over that. And it's just going to display my registration form. User fills out the registration form and eventually they click the register button. Clicking of the register button is going to trigger the on-click event handler that I've defined, which is up here. My on-click event handler does some validation of the data that was entered, and it changes my state variable. Changes it to true. We know from before when a state variable is changed, the component re-renders. So it executes all over again. But now on this occasion, this statement here is going to be true, which means this executes. And what am I doing? I'm returning this special component called navigate. Navigate is a component that I've imported from the React router itself. Now, what the navigate component does is it changes the browser's URL address to whatever we specified here. And we know from old, whenever we change the browser's URL address, then the app consults its routing configuration. And in this case, the routing configuration would tell it to go back to the home page. So this is what I mean by a declarative implementation of programmatic navigation. I'm using this special component provided by the React router. I'm just declaring here what I want to happen as a result of this condition being true. That's declarative approach. If we take the imperative approach, so if I go back to my home page, sorry, not that one. So if we now follow the other option, which is the user clicks on this hyperlink here, that will correspond to this routing option, and we mount the register imperative component. And if we look at that, it's going to implement the same behavior, but it's going to implement programmatic navigation in an imperative style. So the first rendering of this component is just going to cause it to display my registration form. The user clicks on the register button, which means my on-click event handler executes. And in this case, the on-click event handler, it's doing this here. So where did that come from? Well, if we look at this line here, I'm using a special hook provided by the React router. And the hook doesn't take any arguments, but what it returns is a function. This is a function. And I'm using the function down here. And the effect of this function is to change the browser's URL address, current URL address, to whatever I'm specifying here. So this is an ordinary function. that is having the effect of changing the browser's URL address, and what follows then is the same as always. So I'm implementing redirection or programmatic navigation by simply invoking this function. And that's just an imperative style of programmatic navigation. So that's the pattern. Use the hook, it returns the function, and then you can use that function anywhere you want to, but the effect of the function is to change the browser's URL address. So we have really looked at all of the aspects of the React Router library that we're concerned with. There are some other issues, but we don't need them for this module. Overall, we would say that the React Router follows a declarative programming model that was very evident in the routing configuration, in the way we declared our routing configuration. It also favors composition, because we can compose our routing configuration with our own custom components, as we did with the header and footer components. And later on, in a subsequent lecture, we will be composing our routing configuration with some other special types of components. Thirdly, I'm saying here that this is the kind of the execution flow, which is very much kind of based on this model of an event occurs, where in most cases the event is the browser's URL address has changed, but what would precede that is either we have used the link component or the nav link component to affect that URL address change, or as we've just seen, we have implemented it using programmatic navigation. Either way, the browser's URL address has changed. That is modeled as an event by the browser itself. The React Router library handles that event, so it takes care of, consulting its routing configuration, etc. And as a result of consulting the routing configuration, it will mount and unmount components onto the DOM. And whenever the DOMs has been manipulated, then the browser repaints the screen. So this is the kind of flow of control that the React Router follows. And then in terms of the React Router itself, well, it provides us with lots of components and hooks to implement our own custom navigation in our app. The final topic I want to look at is custom hooks. I said there when I was at the end of my discussion on composition patterns that when hooks were introduced into React, they very much changed the whole scene in terms of patterns. A lot of the patterns that were commonly used up to then, they were somewhat deprecated, and developers started using this hooks approach towards implementing their own custom logic. So we can implement, there's lots of hooks that come with the React library. There are hooks that come with third-party libraries. We've just seen some of them in the case of React Router. But we can model our own logic in the form of hooks as well. And I'm just showing you in the remaining set of slides a very simple illustration of a custom hook implementation. And why would we write custom hooks? Well, it's the reason that I've been talking about a lot at the earlier part of this lecture. It's to achieve reusability of some code that we've written. Typically, where a custom hook might come in is if we've got a component that has some state manipulation code, and that code is repeated, let's say, in other components, then that's a classic opportunity to implement a custom hook. So if we take this example here, which looks like it might be from a library management web app, then we've got a component that is retrieving a book object from a web API and storing it in a state variable. And let's suppose that this logic is actually appearing in other components as well, because presumably there may be other pages within our web app that displays book-related information. So what we would do is we would take the code that I have wrapped in the box and simply put it into a function of its own. And now we've got our own custom hook. Because the body of this function contains React state manipulation code. And so it's not just any old function. We would refer to it as a hook function, even though it's implemented as a plain old JavaScript function. But because it is a hook, then I've prefixed its name with the use prefix, because this function can only be invoked at the high level, at the top level within a component. So it has the same restrictions as all hooks do. But other than that, it's a plain old function implementation. And in terms of using this hook function, this custom hook, well, it looks like what you're seeing on the right. Now, hooks, the parameter for my hook function, that's up to you to decide, but it would make sense that ISBN number would be a sensible parameter for my particular custom hook. What the hook returns, in general, hooks tend to return a collection data structure, whether that be an array or an object. And it's really up to you to decide which you want to use. I think so far, any of the hooks that we've looked at return an array, but later on we'll see hooks that return objects. And what entries you put into that collection data structure, it's really up to you to decide what would be useful to whatever component is using your hook. Now it makes sense in this case, I guess, that I would return the book object and a function that allows the user to request another book, i.e. the setter method. So my custom hook, as I'm saying, is an ordinary function, but it can only be invoked from the top level of a React component. Prefix its name with use so that the linters that come with the Create React app check to make sure that I'm using this custom hook properly, or that other people use it properly. And it returns, all hooks tend to return a collection data structure, as I said, because if the nature of what a hook does is state management, then we need to have access to the current value of the state, and we need to be able to change the state. And so hence, I'm returning, in my case anyway, the set book setter method as well as the book instance. There's an interesting website that I came across recently called the Use Hooks website, and it has some really nice custom hook implementations contributed by various developers across the open source community. And you might find a hook in there that you can use in your assignment, maybe not, but it's worth browsing through them anyway. There's a whole list of hooks that have been developed, as I said, by the open source community. There's quite a number of them, because if you scroll down to the bottom, there is a number of pages that you can flick through. And there are some nice hooks in there, as I said. We will implement one custom hook in our Movies app, but that's really only for illustration purposes. I could have done some more custom hook implementations, but just to give you one example, I think we're sufficient.